There are only red marbles and green marbles in a bag. The ratio of red marbles to green marbles in the bag is 4 to 7. Then, well, this name you can pronounce it Julia or Julia because, well, it depends if you're speaking English or Spanish. So, anyways, I'll say Julia. Julia then adds 90 red marbles and 36 green marbles to the bag, which then makes the probability of selecting a red marble from the bag on a random draw is equal to a half. How many total marbles are in the bag after Julia has added the 126 marbles? Well, there's a couple equations that I can write here. We know that 4 to 7 or 4 over 7 is the ratio of red to green marbles at the start. And of course I can cross multiply here and get 4g equals to 7r. Well, we can write a different equation here because we know that at the end, when we've added the extra marbles, the original red marbles plus the 90 marbles to or over the original green marbles plus the 36 marbles equals 1 to 1. Now be careful not to write 1 to 2 because that's the probability that we're going to draw a random marble, because this means that the number of green marbles is twice the amount of red marbles, but we know that is not true. So the ratio is 1 to 1, not 1 to 2. Well, now we can cross multiply again, and we get r plus 90 equals g plus 36. Now you can isolate either r or g and then plug in whatever we decide to isolate into this equation to find whatever we isolated, of course. So I'm just going to isolate the g because it's pretty easy to subtract 36. And everybody in the world knows how to do that. 90 minus 36 is 54. So we get 54, r plus 54 equals g. And you can plug that in here. We get 4 times g, which we now know is r plus 54 equals 7r, and expanding the left-hand side, we get 4r plus 4 times 54, that's 4 times 50, plus 4 times 4, which is 200 plus 16, which you know as 216. We have all that equals 7r, subtracting the 4r, and then dividing by 3, we get, well, 210 divided by 3 is 70. 6 divided by 3 is 2, which means we get 72 equals r, or a more comfy way to say it is r equals 72. Okay, well now I can plug r in this equation. It's sort of funny that you use this equation to plug into this equation, and then when you're done you use this equation to plug it back into this equation. So we get 72 plus 54 equals g, which means g is 126. Now it might be awfully tempting to just say, okay, 72 plus 126, you add it up and you're done. No. We want how many total marbles, again, total is also pretty important, total marbles are in the bag after Julia has added the 126 marbles. Meaning, now we need to add another 126. This is a pretty simple addition. 6 plus 2 is 8, plus 6 is 14, 1 plus 2 is 3, plus 7 is 10, plus 2 is 12, and of course we have 3 ones, which sum up to 324. Now, we're not done yet. There is another way to do this problem, and, well, you can do this way if you want to train your brain, but remember, if you're doing this problem in a competition, like Math Counts, AMC, doesn't matter what competition, remember what matters is speed and accuracy, not how you do a problem. Because, well, you can do a problem, like using like a simpler way, and then go back and review the problem and do it like some way, like something that looks like this. So I'm just gonna erase basically everything except the answer. Then I'll teach you another way, or another way of thinking about problems. If you're in some sort of like place where you're trying to do problems for speed. Now, again, we can think of this as, you know, at the end, we're going to get a ratio of 1 to 1, right? Now, to be more accurate, we know that we're going to get a ratio that is at least 8 to 8, possibly 9 to 9, or even 10 to 10, because what I'm saying is, if you start with 7 parts green marbles, well, if you add 36 marbles, it can't possibly stay 7 parts green, right? Meaning it has to be at least 8 parts green, which means, because the ratio is 1 to 1, red also has to be 8 parts. Now you can check to see this ratio, if this ratio is actually right, by seeing that, well, in the end, we're adding a total of 126 marbles, and in this 4 to 7, I'm just gonna start right here. And we're starting with 4. We're starting with 4 to 7, and then going up to 8 to 8. Well, in the red marbles, we're adding 8 minus 4, 4 parts. And in the green marbles, we're adding 8 minus 7, 1 part, meaning in total, we're adding 5 parts. And, well, each part has to be a whole number, right? You can't, like, add, like, 26 and 2/4, or 26 and a half of a marble, right? That doesn't even make any sense. So we can take the 126 marbles and then divide by 5, which we clearly can't do, which means each part, it will have to be a fraction. We can't have fractional parts, meaning the ratio 8 to 8 can't possibly be our ending ratio. Well, let's try 9 to 9. And you can do the same thinking. From 4 to 7 up to 9 to 9, well, here we're adding, in the red marbles, we're adding, so we can see that, 9 minus 4, 5 parts, and 9 minus 7, 2 parts, which means we're adding a total of 5 plus 2, 7 parts, and again we can divide to see if 9 to 9 could actually be our ratio, while 126 is made from, let's see, well, 70 and 56, and both 70 and 56 are divisible by 7, right? 70 divided by 7 is 10, 56 divided by 7 is 8, which means in all, each part is 18, and we can have 18, right? 18 is a whole number. Now that we know that our ending ratio is 9 to 9, it's pretty simple now, right? Because if our ending ratio is 9 to 9, we have 9 parts red, 9 parts green, which is a total of 18 parts. And if each part is 18, we can just square that. And if you check on your calculator, or do it out on paper if you want, you get the same answer, 324.